R. Demonstrate understanding of time series analyses. Time series analysis evaluates data collected over time to identify patterns. Trend components reflect long-term movement, while cyclical patterns correspond to economic cycles lasting several years. Seasonal patterns occur at regular intervals. Examples include monthly sales increases during holidays or quarterly production variations. Irregular patterns represent random or unpredictable influences. Understanding these components helps managers forecast future performance and adjust budgets, inventory levels, and capacity planning accordingly. S. Identify and explain benefits and limitations of regression and time series analysis. Benefits include forecasting accuracy and quantitative insight. Regression identifies relationships among variables, while time series highlights temporal patterns, supporting planning, budgeting, and risk management decisions. Both techniques rely on historical data. When relationships change due to market shifts or structural changes, predictive accuracy may decline. Limitations include model assumptions and data quality issues. Violations of linearity, independence, or stability assumptions can distort results. Managers must combine statistical findings with professional judgment. T. Define standard error of the estimate, goodness of fit, and confidence interval. Standard error of the estimate measures prediction accuracy. It indicates the typical distance between actual observations and predicted values. Smaller values suggest better predictive precision. Goodness of fit reflects how well a model explains observed data. Metrics such as our superscript 2 help assess explanatory strength and model adequacy. Confidence intervals estimate reliability of coefficients or forecasts. They provide a range within which the true parameter is expected to fall with a specified probability, supporting risk-informed decision-making. U. Explain how predictive analytics techniques draw insights and support recommendations. Predictive analytics uses statistical and machine learning models to forecast future outcomes. Techniques such as regression, classification, and time series analysis estimate probabilities, trends, and expected values. Insight generation requires interpretation and validation. Analysts evaluate assumptions, test model stability, and ensure predictions align with business context and strategic objectives. Recommendations translate forecasts into action. Managers use predictive results to adjust pricing, manage risk, allocate resources, optimize inventory, or revise strategic plans, ensuring analytical findings drive measurable performance improvements. 5. Describe exploratory data analysis, EDA, and how it reveals patterns and insights. Exploratory data analysis, EDA, is an initial analytical approach used to understand dataset characteristics. It involves summarizing key statistics and using visualizations such as histograms, scatterplots, and box plots to detect distributions, trends, and anomalies. EDA helps identify relationships and data quality issues. Analysts can uncover correlations, outliers, missing values, and unusual patterns before formal modeling begins, reducing the risk of flawed conclusions. EDA supports hypothesis generation and model selection. By revealing structure within the data, it guides analysts in choosing appropriate techniques, improving the effectiveness and reliability of subsequent predictive models. W. Define sensitivity analysis and identify when it is appropriate. Sensitivity analysis evaluates how changes in input variables affect outputs. It measures the impact of varying assumptions, such as sales volume, cost rates, or discount rates, on financial results or forecasts. IT is particularly useful in budgeting and capital investment decisions. Managers apply sensitivity analysis when uncertainty exists regarding key assumptions and when understanding risk exposure is critical. Appropriate use involves focusing on key drivers. By isolating variables with the greatest impact on outcomes, organizations can prioritize risk management efforts and improve strategic planning accuracy. X. Demonstrate understanding of simulation models, including Monte Carlo technique. Simulation models evaluate outcomes under uncertainty by modeling multiple scenarios. Rather than relying on single-point estimates, simulations use probability distributions for key inputs. The Monte Carlo technique generates numerous random trials. Each trial produces a potential outcome, creating a distribution of results that reflects risk variability and probability ranges. Simulation enhances risk assessment and decision-making. It is especially valuable in capital budgeting, financial forecasting, and project evaluation where uncertainty significantly affects performance projections. Y. Identify benefits and limitations of sensitivity analysis and simulation models. Benefits include improved risk awareness and decision quality. These tools help managers understand how variability in inputs influences outcomes and assess the probability of achieving financial targets. Sensitivity analysis is simple and intuitive. However, it often evaluates one variable at a time and may not capture interactions among multiple uncertainties. Simulation models are comprehensive but complex. They require reliable probability estimates and computational resources. Results depend heavily on input assumptions and may be misinterpreted without proper expertise.